Today we're going to look at analyzing graphs of polynomial functions. We want you to be able to find zeros, maximums, and minimums on the graph. On your note sheet, there's this problem that says the percent of the United States population that was foreign-born since 1900 can be modeled by this polynomial equation, where t equals 0 corresponds to the year 1900. Notice that the graph here is decreasing from the year 5, or time of 5, all the way to the year 75. Okay, and then it begins to increase. That means the points 5 here, right here, and the point at 75 are turning points. And what we're going to call these are maximums and minimums. So when it up here, when it's higher than all the points around it, that's a maximum. And when it's lower than all the points around it, that's not called a maximum, that's called a minimum. And those are the types of points we're going to be looking for today. So some vocab words, you've kind of heard these before, but kind of talking about them again. When we want to find the zeros of a function, that's the x values where a function crosses the x-axis, or where y is 0. Maximums are the points on the graph where it changes from increasing to decreasing. So when it's increasing and then goes to decreasing, that's a maximum point. Minimums then are the point where the graph changes from decreasing to increasing, where all the points around it, where it's the lowest point for all the points around it. When you talk about max and mins together, we also sometimes refer to those as turning points. So we're going to be looking for zeros, maximums, and minimums on the graph. The first one on your sheet gives us this polynomial, x cubed plus x squared minus 4x minus 4. We want to figure out where the zeros are. Now, they tell us one of the zeros, okay? And one of the things you need to find is the zeros, and they tell us one. One of them, x minus 2, is a 0. So -2 here is going to be one of the zeros of this graph. There's probably some more though, and we want to find those. To do that, we're going to use some of the division stuff that you did earlier in this unit to find it. So since we know -2 is a 0, we're going to put that as our little multiplier. Then we're going to put all the coefficients like we did before with that synthetic division to find out what the other ones are after dividing. So let's divide this 0 into this polynomial. And knowing that it's a 0, when we're all done, we should get a remainder here of 0. So let's start out. The first number, remember, you drop down, then you multiply. If we multiply -2 and 1, we get -2. Write that in the next column. Now you add the columns. 1 plus -2 is -1. Multiply again, two negatives are going to multiply to a +2. Add, you get -2. Multiply again, -2 times -2 is +4. If we add this, yes, again, we get a remainder of 0. Now remember, these numbers, other numbers, are the polynomial that's left over. So this would be x squared minus 1x minus 2. Now to find the other zeros, what we're going to do is take this, set it equal to 0, and continue to factor this out. And if we factor it, we should be able to find the other places where this crosses the x-axis. So now to figure that out, what multiplies to -2 and adds to -1? Looks like -2 and +1 do that. Put both those equal to 0 and solve, and we know the other two zeros now. The other two zeros are going to be 2 and -1. So -2, +2, and -1, at all those locations, we should see our graph pass through the x-axis. Now another way of doing this is also to use your graphing calculator, and it should give us the same points here. If you go on the graphing calculator, hit your graphing button and type in this equation. So let's type in x to the 3rd power plus x squared Then we have minus 4x and minus 4, and type that in and hit graph. We should get what the graph of this one looks like, and you can see it does pass through at those same points we talked about. And then you can also look at the table. The table will give you values to use. So if we hit second graph, it'll give us a list of points. This list then we can write down on this graph. Now, if your table on your calculator doesn't match the table over there, you can change it by going to your table settings, which is right above the window button here. So if you hit second window, then you can specify where you want your table to start. Looks like this one starts at negative 2.5, and we want it to change by half, so 0.5. And then if we hit go back to our table, now it should look like the one over there. So we can fill in all these other values now. We got negative 3.375. This one was 0. And we can fill all these in on there. This one was also 0. And once they're all on there, then we can use these to graph. Now, once you're on your calculator and you kind of run out of here, like one wasn't on there, you can just scroll down and you can find some other ones on there and use that to fill the rest of them in here. Okay, and notice how these ones are matching exactly what we had right here. Okay, so those should match. The rest of the points now, if you put those dots on the graph, we should have an idea of what this one looks like. So if you kind of estimate negative 2.5, negative 3.75 is going to be about there. Negative 1.5, 0.875 is going to be about there. 0, 1, 2, 3, right about there. That one's going to be right about there, there, and right about there. So now if we connect them, we get an idea of what this one looks like. Okay, now the next thing that they want you to find is what is the minimum and maximum. You can estimate that from what you have on the graph there. So where was the maximum at? It looks like the maximum occurred right here, and it's about at, looks like it got to about roughly 0.9, and we can estimate it, it's pretty close to 0.9, and that occurred roughly at negative 1.5. Where's the minimum at? Looks like it got down to pretty close to negative 6. Okay, that's this point right here. And it occurred pretty close to 1. So once you got that, then you can fill those in. The last thing that this one wants is you to identify what is the end behavior. What's the end behavior of the graph doing? The end behavior of the graph is what the ends are doing. Okay, so as x approaches infinity, remember that's kind of like the right side of the graph. What's it doing on the right? This is going up to positive infinity. So that one's approaching infinity. As x goes to negative infinity, that's as you move left. As we move left on this graph, it keeps going down. That's going to negative infinity. So we can fill that in. Another way to tell that is looking at this equation. If the first number is positive, or the biggest degree is positive, you know then that the right side is going to be going up. So that would be increasing to infinity there. If that had been negative, if there was a negative in front of that, then it would change the opposite direction. And then we know odd ones are going to be opposite direction. This is an odd degree one, so if it's odd, you know they have to be going opposite ways. If it'd be even, then we know they're pointing the same way. All right, let's try another one here. This one's on the back. We want to do the same thing, find the zeros. Okay, so let's start by doing synthetic division. It tells us 4 is a 0. So if we put 4 in our box, put the coefficients 1, -4, -1, and +4 here. Let's see what we get. Okay, multiply, add, multiply, add, multiply, add. Looks like again we get remainder of 0. Okay, so our polynomial that's left is x squared plus 0x minus 1. Another way we could write that as just x squared minus 1. How does that factor? That's one of those difference of squares ones. Okay, you got x and x. What multiplies the -1 and adds the 0? +1 and -1. Setting those both equal to 0, you're going to get -1 and 1. So now we can fill in what the zeros are. The zeros on this one are going to be -1, 1, and the one that they gave us, 4. That's the one from up here. Okay, so on the graph, you know, -1, 1, and 4 are all going to be part of this. We could also identify the end behavior right now, even without getting the rest of the graph. Since this one is positive right here, this side we know is going to be increasing. This side should be decreasing. So this one's going to be infinity and negative infinity. And the reason I knew they go opposite directions is it's an odd degree one. Odd degree ones are going to point opposite direction. So since I know the right side's going up, that means the left side's got to be going down. So it looks like we probably are going to have some kind of maximum here and some kind of minimum here. The only thing we need to know is how far down does it go and how far up does it go. Your calculator can help you identify this. There is a way to find maximums and minimums on your calculator. So let's type in this function for this one, x cubed minus 4x squared minus x plus 4. So once you got that function in, then we should be able to graph it out here. And the graph's going to look something like this, similar to what we got. In order to get the rest of it, we want to know where that max and min is. Your calculator can do that. Right next to the graph button, it says trace, and right above that, it says calculate. If you go to that calculate menu, minimum and maximum are on there. So if you scroll down to minimum, you can see where this minimum is going to be. Now, looking at the graph, we know the two zeros around that are at 1 and 4 here. So when your calculator asks, we want to point to the left of the minimum, you can enter 1, because we know 1 is a point to the left. Now it says what's a point we know is to the right, we can enter 4 and hit enter. And then it says take a guess and then hit enter one more time, and your calculator will guess where that minimum will be. And it looks like the minimum, the lowest this is going to occur, is at -8.2. That's the lowest this graph gets. And it occurs pretty close to 2.78. We'll round that to 2.8. So at 2.8, which is pretty close to 3, it gets all the way down just a little past -8. So somewhere right about there. So that will be our minimum point there. That's what that side of the graph looks like. Now you can do the same thing and find your maximum. So to find the maximum, hit second again and this trace button to get the calculate menu, select maximum number 4, And then our maximum we see occurs between -1 and 1. So if we type in the point to the left, -1, hit enter. Pick a point to the right now, +1, hit enter, and guess, hit enter again. It'll estimate for you where that maximum is. Looks like the maximum gets not, it's, it looks like it's just a little bit above 4, so maybe about 4.1 there, 4.06 or about 4.1, and it occurs very close to 0. It looks like just a little bit to the left of 0, -0.1. So now on the graph over here, find that point, which is right about there, and that would be the maximum. So that's roughly what this graph looks like. And that's what you're doing on these problems, finding the zeros and the max and mins. When you get into, if you go on to do like business or engineering, that kind of stuff, those are the very important points usually where you're trying to seek out information and figure out what's happening, what's causing the max and min and the increasing, decreasing, and the zeros. All right, here's another one. Why don't you pause the video, see if you can do the synthetic division here to find this one. All right, let's see what you got. -1 is the one that they told us. We got the coefficients here of 1, 1, -4, -4. Now you gotta be careful on this one. Notice that we don't have any degree 0 here. It's missing, which means you gotta fill that in as one more 0. If you didn't do that, put it in now. Okay, so if we do this, you got 1 times, you got -1, add, you got 0. Multiply again, anything times 0 is 0. -1 times -4 is +4, 0. Multiply, you get 0, and you do get a remainder 0. So the rest of this is your polynomial that's left. Now here, this first one's going to be x cubed plus 0x squared minus 4x plus 0. We don't need to include those 0 ones. The rest of our answers are going to come from that. Now, how do we factor that one? Well, notice both terms have an x. We can take one x out then. We can take out the greatest common factor of an x. Okay, so how does the rest of that? Well, the rest now, that's one of those difference of perfect squares. That would be x and x, and then positive and -2. So now set all three of these equal to 0, and we will get our last one, looks like 3 here, of 0, -2, and +2. And don't forget about our -1 up there. So those would be all of our zeros. So we want to fill those in here. So we got -2, -1, 0, and 2. Put all those on the graph. All 4 of those places it should pass through the x-axis. Okay, now we got to fill in what are the maximums and minimums. This one's positive, and so we should know that on the right side here it's going to be increasing, but this is a even degree polynomial, which means both arrows should be pointing the same way, so it should also be increasing on this side. On our end behavior, both of these here should be positive, and so we can fill that in. These should both be positive infinity. All right, now to get the maximums and minimums, use your calculator to help you out. So type this equation in, and we can see what those are going to be. So if you go to your y equals, type it in. Here's what the graph should be looking like. I think I hit the wrong button somewhere. 4x. Oh, yep, this one should be plus. Try it again, hit graph. There we go. So it looks like we kind of get a W-type shape here. To figure out where those maximums and minimums are, it looks like there's one maximum, two minimum. Use what we did before. Let's find this minimum to the left. So if you go calculate minimum, looks like the 0 to the left of it's at -2. The 0 to the right of it's -1. Guess, yep. And it tells us the minimum's at -1.3. So at -1.3, there's a minimum, and the x value, the location that it happens at, it's about -1.6. So if you find that on here, -1.6, go down about 1.3, maybe right about there. There's the minimum. Okay, see if you can find the next maximum and minimum. All right, if you did it correctly, the relative maximum is going to be at about 0.9, and the x value is very close to -0.5, and so it's just a little bit under 1 there. That's the maximum, and then the other minimum is pretty close to -6.9, and it happens at about 1.3. And so just a little bit above 7 there. So it comes all the way down here and comes back up. So that's what the graph of this one looks like. Now, if you were struggling and did have a graphing calculator, you could estimate it pretty close. Like if you found, okay, here we know there's one at 0 and 2. Looks like the maximum's probably going to happen very near 1, and you could plug 1 into the function up here and estimate it that way. Would be another way you could do it if you didn't have a graphing calculator. Same thing here. If you knew there was one at -1 and 0, where's the minimum location of the minimum gonna be? Probably pretty close to -0.5, and then you could plug -0.5 in there and find out it's gonna happen very close to that. So that would be a kind of a workaround if you didn't have a graphing calculator. All right, last problem. Here they say the average fuel in gallons consumed by individual vehicles in the United States from 1960 to 2000 is modeled by this cubic equation. Where is the number of where T is the number of years since 1960? Estimate the maximum average fuel consumption and give the year that it occurs. Well, the maximum, from what we know, is where it goes from increasing to decreasing. Looks like there's the maximum. Now you got to estimate, what is that? Well, the maximum is right about there. Looks like this graph is going up by 50s every 2 lines. So we know this line right here is 725. I don't know. Looks like it's a little bit more than half there. Maybe about 715 is where this is at. And then you got to find the location. Looks like it occurs in the year, looks like that would probably be, well, this is 5. And so this might be about 7 years after. Now it's 7 years since 1960. So that would mean this happened in about 1967. Okay, estimate the minimum. Here's the minimum here. Okay, that looks like maybe it's about year, well, here's 35, so this might be about year 33. If we add 33 years onto that, that's about 1993. So in 1993, fuel consumption hit the lowest point. What is that lowest point? We follow it over and estimate, I don't know, maybe that's about 520 gallons per year. Looks like the lowest. So those would be the maximum and minimum points. All right, so just be aware of what maximum and minimums are. Those are the ones that you want to find, Because then what you would do is figure out, okay, why did it hit a minimum in 1993? What was going on in the country that led to the low fuel consumption? Maybe gas prices were very high, so people didn't drive as much. How come in 1967 people were using so much gas? Was there a lot of transportation going on? Was there something happening that caused that? That's what math is good for, and you can find out stuff and then investigate why. All right, you try those on the practice.